The solution of the stationary part, that is the solution of the non-homogeneous differential equation, is quite simple. So this is the non-homogeneous equation which I copied, and I put the index st for stationary because it's valid only for the stationary. So Vst dot is equal to minus 0.05 Vst plus 0.001 F0. Don't forget that F0 is a constant value. And now I put t is non-negative, because if we go back for a moment to the solution of VTR, as you can see here, I draw the VTR for the negative t's too. But now we define that the t is non-negative. So as I mentioned you, the stationary part is simple because F0 is constant. That's why we can say that Vst, which is a time function, is constant. So we can select the stationary part as constant because the input is constant. So the stationary part is depending on the input signal. If the input signal is constant, then the stationary part is constant. But the value is not known yet. This is why I defined it as k, and now we are going to calculate the value of k. For example, if the input signal is a sinusoidal signal, the output signal, the stationary signal, will be sinusoidal too, as we will see it later in a separate block of the lecture notes. But now the input is constant, the stationary is constant. So let's put back this to here. So k dot is equal to minus 0.05 k plus 0.001 F0, and t is non-negative. So I just copied k back to the non-homogeneous equation. K is constant, k dot is 0. This is minus 0.05 k, so I just copy the last equation. And if we solve it for k, we are going to get 0.02 F0. So F0 is a given value, and now the non-homogeneous part is ready. So it means that Vst is a constant value. Now the stationary part is